Hello again, my name is Richard. Welcome. Today our discussion on logarithm will be on equation involving logarithm. Today before the lesson ends, we will learn how to solve equations that involve logarithms except simultaneous equations that involve logarithm. This will be a very interesting engagement, so please watch the video till the end. So prior to this, we learned the laws of logarithms. And we say that if we have a log having two same bases and we are adding, we can just repeat the base and multiply the logs. So we say log s base a plus log y base a is equal to log sy base a. We also say log s base a minus log y base a is equal to log x over y base a. Then the third law, log s exponent n base a is equal to n log s base a. Then we say this one is called change of base. That's log b base a can be equal to log b base c over log a base c. Then we also talk about some properties. One of the essential one which we'll be using today is that if you have log b base a is equal to c, then we can say b is equal to a exponent c. Please, if you don't know how to prove all these properties, check out my videos on laws involving logarithms on YouTube. So today, we'll solve some problems, some equation problems that involve the use of these laws as well as their property. This will be a very interesting engagement as I told you, so please come with me. So let's look at our first question. It said, find x if log 5x plus 3 base 2 is equal to 3. So remember, we said that if you have log b base a and is equal to c, then b is equal to a exponent c. Then we can say, in this our case, if we have log 5x plus 3 base 2 and is equal to 3, then we can say that 5x plus 3 is equal to 2 exponent 3. I hope you get that, using that property. So we say 5x plus 3, 2 exponent 3 is 8. So 5s will be equal to 8 minus 3. 5s is equal to 5. When we divide both sides by 5, s will be equal to 1. I hope you get that. This is very simple. We just use the property to get the answer. So our second question said that given that log 3s minus 7 base 5 is equal to 1, we should find the value of s. Please pause the video and try solve it. After that, you compare our answers with mine. So using the property again, if you have log 3s minus 7 base 5 and is equal to 1, you can say 3s minus 7 is equal to 5 exponent 1. You can say 3s minus 7 equal to 5. 3s is equal to 5 plus 7. 3s will be equal to 12. On divide both sides by 3, our s is equal to 4. I hope we had 4. So the correct answer is 4. So the next one says, if 5 exponent s is equal to 9, we should find the value of s. So at first sight, you may try to use indices to solve this. However, there is no number or there is no any direct number exponent that the base is 5 and we'll get 9. So we don't have any direct number is that. 5 exponent 1 is 5, 5 exponent 2 is 25, it's not 9. So we use log to do it. How do we do it? We find log of both sides. So taking log of both sides. So we can say log 5 exponent s is equal to log 9. Remember, when a log is written without the base, it's in base 10. So the third property, we will apply the third property here. Then this will be x log 5 and it will be equal to log 9. Then our s will be equal to log 9 over log 5. When we divide both sides by log 5. So s will be equal to, if you point log 9, you get 0.9542. And log 5 is 0.6990. When we divide this by this, we we get 1.37. Then we say x is equal to 1.37. Correct to 2 decimal places. I hope you get this. So far, if the number here, we don't have the base exponent, any number that will give you the number there, you can't use indices. You need to use logarithm to solve it. I hope you get it. So let's look at our fourth question. Our fourth question is, if log 2x base 2 plus log 8x base 2 is equal to 4, we should find the value of s. Please check out this law. The law says that if two logarithms are added, okay, with the same base, then we can multiply the logs. So we'll use that law to solve this. So we can say this will be log 2x times 8x base 2 will be equal to 4. So we have log base 2x times 8x will be 16x squared, and it will be equal to 4. Then we use the property. So we say 16x squared will be equal to 2 exponent 4. 16x squared will be equal to 16. 2 exponent 4 is 16. We divide both sides by 16. X squared will be equal to 1. We'll find the square root of both sides to get x. So the square root of every number is plus or minus. So we say s is equal to plus or minus 1. I hope you get that. So the answer is 1. So make sure you find out which of the law is applicable. You apply that law and the property, then you get the answer. So our fifth question is, given that log 2x minus 5 base 3 minus log s minus 1 base 3 is equal to 2, we should find the value of x. Please remember this law. It says that when two logarithms are subtracted with the same base, we just repeat the log and the base, then the logs will divide. We say log s base a minus log y base a is equal to log x over y base a. We'll use that law to do this. Since they are subtracting, we'll use that law. So we will have log 2x minus 5 base 3 minus log x minus 3 minus 1 base 3 is equal to 2. We can say this will be log 2x minus 5 over x minus 1 base 3. Since they are subtracted, we can divide. Is equal to 2. Now we apply that property. Then we can say 2x minus 5 over x minus 1 is equal to 3 exponent 2. This 3 exponent 2. So 2x minus 5 over x minus 1 will be equal to 3 exponent 2 is 9. So what do? We can cross multiply this. So we have 9 times 9 will multiply this. X minus 1 will be equal to 2x minus 5. So when we expand this bracket, we get 9x minus 9 equal to 2x minus 5. We group like terms, we get 9x minus 2x equal to negative 5 plus 9. 9x minus 2x is 7x. Negative 5 plus 9 is 4. We divide both sides by 7. Our s is 4 out of 7. I hope you get that. So our next question, please, you are free to pause the video and try to see if you can solve this. Find the true set of the equation 1 plus log x squared minus 4x minus 16 base 2 equal to log x squared minus 3x plus 4 base 2. So how do we solve this? I can bring this here and send that one there, and send the one there. You can say log x squared minus 4x minus 16 minus log x squared minus 3x plus 4 base 2 will be equal to negative 1. See, I send a negative 1 there. And the 1 there to become negative. So we apply. Since they are subtracting, we divide. So we say we have log x squared minus 4x minus 16 over x squared minus 3x plus 4 will be equal to negative 1. What do? We apply that property. So we can say x squared minus 4x minus 16 over x squared minus 3x plus 4 will equal to 2x power negative 1. 2x power negative 1 is half. So we can say x squared minus 4x minus 16 over x squared minus 3x plus 4 will be equal to half. So we can cross multiply this. So we can say 2 times x squared minus 4x minus 16 equal to 1 multiply this will still be the same thing, plus 4. So when we distribute the 2 over, we will get 2x squared minus 8x, then 2 times 16 will be 32, equal to x squared minus 3x plus 4. And we can bring everything here, equate it to 0. So we can get 2x squared minus x squared minus 8x, then plus 3x minus 32 minus 4 equal to 0. So 2x squared minus x squared will be x squared, minus 8x plus 3x will be minus 5x, then minus 32 minus 4 will be minus 36 equal to 0. This form a quadratic equation. We find the factors of 36. When we add, we get negative 5. We multiply, we get negative 36. So those factors are negative 9 and 4, or 4 and negative 9. 4 and negative 9. 4 plus negative 9 will be negative 5. Then 4 times negative 9 will be 36. So since we know that the factors are negative 4 and 9, we change the linear term to that. So we can get x squared minus plus 4x minus 9x minus 36 will equal to 0. Then we bracket the first two and the last two. What's common here? X. We factor it out. We have x plus 4. What's common here? 9. X plus 4 equal to 0. So we factor out x plus 4. Have x minus 9 equal to 0. So we take each of them, equate it to 0. We get x to be negative 4 or 9. So since the equation says we should find true sets, we say x is such that x is equal to negative 4 or 9. Please pause the video and see if you can solve it. So given that log x minus 4 base 2 plus log x minus 8 base 2 minus log 5x plus 4 base 2 is equal to negative 1, we should find the values or the value of x. So how do we do that? Remember the laws. When they are adding, we multiply. When they are subtracting, we divide. Then we can say that if we have log x minus 4 plus log x minus 8 all in base 2 minus log 5x plus 4 base 2 and it's equal to negative 1. Since these are adding, we can let them multiply. So we can say x minus 4 times x minus 8 minus log 5x plus 4 equal to negative 1. Since this is subtracting with the same base, we can let it divide. So we can say log x minus 4, x minus 8, all over 5x plus 4 equal to negative 1. I can expand this. So I'll say log, this times this is x squared, this times negative 8x, negative 4x, then negative 4 times negative 8 will be plus 32 over 5x plus 4 equal to negative 1. So I'll simplify this further. We'll have log base 2 x squared minus 8x minus 4x will be minus 12x plus 32 over 5x plus 4 equal to negative 1. So we apply the property. Then we can say that x squared minus 12x plus 32 over 5x plus 4 will equal to 2x power negative 1. So you can say x squared minus 12x plus 32 over 5x plus 4. 2x squared negative 1 will be half. So how do? We can cross multiply. This will multiply this and this multiply that. So we say 2 bracket x squared minus 12x plus 32 will equal to 5x plus 4. This multiply this will get 2x squared. This times this will be minus 24x. And this times this will be plus 64 equal to 5x plus 4. Now we'll bring everything here equate it to 0. So we'll get 2x squared minus 24x minus 5x plus 64 minus 4 equal to 0. And we'll simplify further. We'll get 2x squared minus 24x minus 5x will be minus 29x. Then 64 minus 4 will be plus 60 equal to 0. So this becomes a quadratic equation. So how do we solve that? Remember the coefficient here is not 1. So we need to multiply this 2 by 60. 2 by 60 will be 120. So we find factors of 120. 1 will add, we get negative 29. We multiply, we get 120. That will be negative 5 and negative 24. See, negative 5 plus negative 24 will be negative 29. Then negative 5 times negative 24 will be 60. Then we change this linear term into those factors. So we can say we have 2x squared minus 5x minus 24x plus 60 will be equal to 0. So we bracket our first two and allow us to factor out common factors. What is common here? X. You have 2x minus 5. What is common here? 12. So 12, negative 12 out. You have 2x minus 5 equal to 0. 2x minus 5 is common, so it will be out. You have x minus 12 equal to 0. So we take each of these equate it to 0. So when 2x minus 5 is equal to 0, 2x will be equal to 5. Then we divide both sides by 2. X will be equal to 5 out of 2. Then x minus 12 is equal to 0. X will be nothing but 12. Then we can say s is equal to 5 over 2 or 12. So let's look at our next question. They say find the value of s given that log 2x plus 1 base 3 is equal to log 49 base 7. So you realize that the bases are not the same. So this is called a change of base. So we are going to use this law, which says that log b base is equal to log b base c over log a base c. So we change any of the logs by introducing another log with a different base. So I can say this, either this side or this side. I want to change this side. So I can introduce a log of base, maybe 4. So I can say log 2x plus 1 base 3 will be equal to, so when we introduce that base, we have log 49 base 4 over log 7 base 4. So we change the base. This is a change of base, the fourth log. So have log 2x plus 1 base 3 will be equal to, so I can write this in an exponent form as log 7 exponent 2. 49 is 7 exponent 2 over log 7 base 4. So we apply the third law here by dropping off the base. So we can say log 2x plus 1 base 3 will be equal to 2 log 7 base 4 over log 7 base 4. So log 7 base 4 can just divide log 7 base 4. What will be left there will be 2. So we have log 2x plus 1 base 3 is equal to 2. So now we apply that property. We can say that 2x plus 1 equal to 3 exponent 2. So 2x plus 1 will be equal to 9. So we can say our 2x will be equal to 9 minus 1. 2x will be equal to 8. We divide both sides by 2, and x will be equal to 4. So please, if we find out that the bases are not the same, we apply the fourth law that's involving a change of base. So we'll solve one more question that involves a change of base. Please, before we do that, remember to subscribe to the YouTube channel if you are here too, and click on the notification bell. Please, your comments keeps me going, so please let your comments count, and it will help me and it will help the two of us. So let's solve this. It involves a change of base. You say if log 16 base 2 is equal to log 4x plus 9 base 3, we should find x. So we change the base. We can introduce a log to any base for one of the sides. So I want to do it for this. So I want to introduce a log of base, maybe 5. So I'll have log 16 base 5. Remember the change of base over log 2 base 5. And it will be equal to log 4x plus 9 base 3. So we can rewrite this as 2 exponent 4 is 16 over log 2 base 5 equal to log 4x plus 9 base 3. So we apply the third law by dropping off this exponent. So we have 4 log 2 base 5 divided by log 2 base 5 will be equal to log 4x plus 9 base 3. So log 2 base 5 can divide log 2 base 5. We have 4 equal to log 4x plus 9 base 3. So our log 4x plus 9 base 3 can be equal to 4. So when we apply our property here, we can say 4x plus 9 will be equal to 3 exponent 4. So 4x plus 9, 3 exponent 4 is 81. So 4x will be equal to 81 minus 9. 4x will be equal to 81 minus 9 is 72. 72 divided by, we divide both sides by 4. 72 divided by 4 is 18. Then we can say x is 18. Please, we'll end it here today. Remember to subscribe to the YouTube channel. Until we meet again, my name is Richard.